Hi, now we have seen the fundamentals to deal with rolling motion, and in this episode I'm going to talk about a very important thing, which is the concept of rolling with slipping and rolling without slipping. So rolling without slipping is also called as pure rolling, right? So before I tell you about these two types of rolling, first of all let me explain you the meaning of slipping. So what is the meaning of this word slip? When does anything slips, right? So let me give you an example. Let's say this is a table or a plank or anything which is fixed, and let's say this block is moving over the plank. Now I have left some gap between the points of contact, so you can imagine that this block will not just be in air and move on the plank. That's not possible. So of course this block is kept. I have intentionally kept some gap here. Now these two are the points in contact, right? In fact, all these points are in contact. So let's focus at the contact points. Now, the meaning of sleep. I'm sorry, I'm just slipping my tongue here. So the meaning of slipping is that two things will not slip over each other. Will not slip over each other if their points of contacts have same velocities and same accelerations. So let's say this plank is at rest, this is fixed, then what is the velocity of this point of the plank? It's 0, right? Then if this point of the block also has a velocity of 0, it means that these two things, the block is not slipping over the plank. This is the meaning of slipping. And if this plank, let's say, has a velocity of v, right? Then tell me, if this is translating with a velocity v, what is the velocity of this point? The velocity of this point is also v. Now, tell me, if the velocity of this point is 0, if this is still 0, it means these two are not same. It means that the block is now slipping over the plank. And if the block somehow achieves the velocity v, then the velocity of these two points of contact remain what? They again become same, and then in this case they are not again slipping over each other. So let me give you another example. So let's say this is ground, and this is something kept over ground, and again this is the point of contact. So let's say we zoom in. So for that, what I'm going to do is that I'm going to leave a gap between the points of contact. So these two are the points of contact, right? So what is the velocity of ground? The velocity of ground is 0, right? If you're looking from the ground. So if this point is having a velocity of 0, then if this object has to not slip over the ground, what should be the velocity of this point? Tell me, the velocity of this point should be 0, right? Then if the velocity of this point is also 0 and the velocity of this point is also 0, it means these two things are not slipping over each other, or we can say that this thing is this is disc or a sphere or a ring or whatever, this is not slipping over the ground. But if the net velocity of this point is somehow v, it means that these two things are slipping. So now you understand what is the meaning of slipping. When one thing slips over other, whenever you have to check that if things are slipping over each other or not, what you are going to do? You are going to check the velocities of their points of contacts. If they are same, they are not slipping over each other. If they are different, it means they are slipping over each other. And you can understand it. So if this is at rest, and if this point has a velocity, some velocity, it means this point is moving with respect to this point, right? That's why we said that. So the definition of slipping, we can give that any object slips on other object if their velocities of their points of contact are different, and if it does not slip if the velocities of their point of contacts are same. So this is the first thing that you need to remember. I hope you are noting down the important points that we are discussing here. All right. So now let us talk about the role of friction that comes into picture. Right now, there are two types of friction. We understand that. The two types of friction are static friction, and the second type of friction is kinetic friction. Now, let me tell you one thing. The story of friction here is very important, and in fact, sometimes I prefer calling friction as the bad boy of physics, or the bad guy in physics, in fact, because the friction can change its value. Actually, kinetic friction does not change its value. Static friction can change its value from 0 to a maximum value of some maximum value. I am calling that F max, right? So I'm just revising some basic concepts of friction for you. And kinetic friction has a fixed value, which is mu n. The kinetic friction between two objects has a fixed value, which is mu, and normal force acting between these two objects. All right. Now, why I'm talking about friction? Understand one thing. Whenever let's take this example, and I'm telling you that I'm leaving a gap between the 2 points of contact. Let's say this object is slipping over ground. Let's say this ground. If I'm making like this, you can understand that there's a fixed ground. So if this object is slipping over ground, wherever there is a slipping between any two surfaces, the friction between these two surfaces is of kinetic kind. Understand this. Whenever there is slipping, the friction is kinetic. And that's why this case is easier. If there is slipping, that is a simpler case, that is an easier case. But wherever there is no slipping, if the velocity of this point and velocity of this point is same, at that time when there is no slipping, the friction is static. So first thing that you need to check is whether they are slipping or not. You know how to check that. You know how to check that whether two things are slipping over each other. Once you understand that whether they are slipping or not, you can easily understand what kind of friction is there in between. If they are slipping, friction is kinetic. If they are not slipping, friction is static. All right. So this is the dangerous part, because if friction is static, not a dangerous part actually, I just said in a flow, but the tricky part actually, you can say. Because if there is no slipping between the surfaces and the friction is static, then friction can have any value. It can be 0 to a maximum value, and F max is actually also mu n. The maximum value of friction is coefficient of, you can say that this is mu s, coefficient of static friction, and this actually here is mu k, which is coefficient of kinetic friction. So this is mu s, coefficient of static friction, into n, that is the maximum value of friction. So this is the part where you have to take care. So whenever we have given that anything is pure rolling, right? Now let me tell you what is the meaning of pure rolling and what is the meaning of not pure rolling. So you can understand it simply. Pure rolling is when it is rolling without slipping. Not pure rolling is when it is rolling with slipping, right? So whenever it is rolling in such a way so that it is slipping also, that is the case of not pure rolling, or simply rolling with slipping. And whenever it is rolling in such a way that it is not slipping, that is the case of pure rolling, right? So now let me give you some examples of this scenario. Before we go to the problems and discuss them, let me give you one example here. So let's say that this is the thing which is having a translational speed of v and a rotational speed of omega, right? And this is the ground, and we have to check that what kind of friction is acting between these two things. Let's say the surface has friction. See, if the surface is frictionless, then there is no friction. There is no meaning of this question at all, right? But if there is a friction on the surface, then if we have to figure out what kind of friction is acting between these two. So how we are going to check this? Now let me tell you. Tell me so first of all, first thing you are going to check is that whether it is slipping or not, right? How will you check that? You will find velocity of this point, then you are going to find velocity of this point, and you are going to match. If they match, it's not slipping. If they do not match, it's slipping. So tell me, what is the velocity of this point here? Again, we have to find the velocity of this point of this rolling object. What we are going to do is break it into two parts. We can understand. We just did it in the previous episode. This translating with a speed v, and the second part that it is rotating with some omega. At this time, forget rotation. At this time, forget translation. Due to this, if translational speed is v at this point, what is going to be translational speed at this point? It's going to be v. Now, if this is omega, if the rotational speed here is omega, rotational speed of all the points is going to be omega, and at this point it's going to be what? Omega r if the radius is r. So what is the net speed of this point? V in this direction due to translation, and omega r in this direction due to rotation. They are opposite. Velocity is a vector quantity. So what is the net velocity of this point? So net velocity of this point is, if I take this direction to be positive, it is v minus omega r. See, if I have taken this direction to be positive, so v comes positive and omega r comes negative. Alright. So the net velocity of this point is v minus omega r, and net velocity of this point is 0. Now think about this. There are three cases possible. First case is if v is greater than omega r. Tell me, v is greater than omega r, can this velocity, this part, so this I am writing actually as, I'm calling this point as point P, and I'm writing this as Vp So Vp, velocity of point P is what? V minus omega r. Tell me, in first case, if V is greater than omega r, can Vp become 0? It's not possible. For Vp to become 0, these two must be equal, then only Vp can become 0. So if V is greater than omega r, it means it is sliding or slipping more in this direction, because net velocity is going to be in this direction, right? And in this case, it is slipping because this is 0. This we understand that if I call this as point E, Earth's point, so velocity of Earth's this point is equal to 0. So if V is greater than omega r here, it means that this point is having a non-zero velocity, and it means that these 2 points have different velocities. It means this is slipping. So if V is greater than omega r, there will be a slipping. And if there will be a slipping, what kind of friction there will be? There is going to be a kinetic friction. And we understand what is the value of kinetic friction? Mu n is going to be the kinetic friction. What is the second case? If V is less than omega r, if V is less than omega r, then again tell me, if V is less than omega r, again this value cannot become 0. So Vp will, if V is less than omega r, Vp will still not become 0. And if Vp is still not become 0, but this whole value will become negative, it means it is slipping in this direction. And there is slipping because this point's velocity is 0 and this point's velocity is not 0. And that's why this rolling object is slipping. And in these two, this here also, again there is a slipping, and that's why there will be a kinetic friction and the value will be mu n. And these two are the cases of rolling with slipping. In this condition, first condition, it is slipping forward. In this condition, it is slipping backwards, because you understand that here V is greater than omega, so net velocity is positive. Here V is less than omega, so net velocity is negative of this point where I'm talking about. Alright, now third case, the beautiful case, most beautiful case but still tricky case. If V is equal to omega r, tell me, V is equal to omega r, what is the meaning of this point? If V is equal to omega r, then simply, what is the net velocity of point P? In this case, the net velocity of point P is going to be 0. And what is the velocity of this point? The velocity of this point is also 0. That's beautiful, right? So if the velocity of these 2 points are 0, it means they are not slipping. So if V is equal to omega r, they are not slipping. And if they are not slipping, understand, friction is static. And friction static can be anything from 0 to mu n. So never try to guess the value of friction. And never say that friction is 0 if it is not slipping. See, understand, if two things are not slipping over each other, there is static friction between them. And static friction can be anything from 0 to a maximum value of mu n. It doesn't mean that friction is 0. So the main key takeaway from this episode is what you're going to take is that how you are, first of all, whenever you have a rolling problem given, if it is already told that it is pure rolling, then you understand that okay, it is not slipping. Alright, but if it is not told, then always check whether it is slipping or not. Let me tell you, in most of the problems that you will solve, you will get, see, 80-85%, I don't know what percentage, but most of the problems you actually get from pure rolling, where there is rolling without slipping, right? So that most of the times you will not have to check. Alright, so but if it is not given, always check whether it is slipping or not. If it is slipping, friction is kinetic, right? And always check that in what direction it is slipping. So like in first case, let me tell you one more thing, I'll just conclude that if in this first case, because V is greater, it is slipping in forward direction, so friction will always act in what? Backward direction. Friction always opposes slipping. So if it slips in forward direction, friction will act in backward direction. In the second case, where V is less than omega r, it is gonna, because omega r is more, V is less, so it is gonna slip in backward direction. The net velocity of this point is in backward direction, so it will slip backward, and hence the kinetic friction will act forward. If V is equal to omega r, it means that this point net velocity is 0, and here also the net velocity is 0. And what do we conclude? We simply conclude that this is the case of no slipping. So check whether it's slipping or not. Once you are sure whether it's a case of slipping or not slipping, you can figure out about what kind of friction is acting there. Now in next episode, let's take this topic forward and see problems and some more concepts. Thank you.